Hi, this is MCQ number 10 on the AP Physics C extra credit questions. So here we have a wordy problem. Not numbers aren't really relevant in this one, but these types of problems is very important to read carefully. So let's read it together. Identical blocks 1 and 2 slide on a horizontal surface toward a stationary barrier. What's this? Right here. At time t equals 0, block 1 collides with the barrier and slides backwards. The blocks collide at time t equals delta t. Assuming friction between the blocks and the horizontal surface to be negligible, which of the following is true about the two blocks? Okay, so both blocks are moving to the left. Then when block 1 hits the stationary barrier, it starts moving to the right, and then inevitably they're going to have collision right here. So we're asked to try and identify which what it really comes down to is what type of collision is this. So let's go to our physics facts and energy in a collision. In an elastic collision, mechanical energy of the system, mechanical energy is potential energy plus kinetic energy. So the total energy of the system is conserved. Collisions for which objects stick together cannot be elastic. That'd be perfectly inelastic. And then collisions for which objects bounce off each other may or may not be elastic. Right. Okay. So if the collision between block 1 and the wall is elastic, and the two blocks have an elastic collision, so this collision at t equals 0 is elastic, and t equals delta t between the blocks is elastic, then the sum of the kinetic energy of blocks 1 and 2 before block 1 makes contact with the wall will be equal to the sum of the kinetic energy of blocks 1 and 2 after the collision between the blocks. Yeah, that's true. The total energy of the system before the collision between the two blocks was the sum of the energies of the blocks at t equals 0. And then if it's elastic, it should equal the sum of the kinetic energy of blocks after the collision. So let's select that, but then let's go through the other ones. If the collision between block 1 and the wall is elastic, and the two blocks have an inelastic collision, then the sum of the kinetic energy of blocks 1 and 2 before block 1 makes contact with the wall will be equal to the sum. So no, that's not true, because that would only be true if both collisions are elastic. If this collision is inelastic, then it wouldn't be the same. So no, B is not true. CC. If the collisions between block 1 and the wall is not elastic, and the two blocks have an inelastic collision, then the sum of the kinetic energy of blocks 1 and 2 before block 1 makes contact with the wall will be less than the sum of the kinetic energy. So no, that's not necessarily true. It could be true, but doesn't have to be. If the collision between block 1 and the wall is not elastic, and the two blocks have an inelastic collision, so nothing's elastic, then the momentum of block 1 before it makes contact with the wall will be equal to the sum of the momenta of the two blocks after the collision between the blocks. So this is interesting. It talks about the momentum. The momentum of block 1 before it makes contact with the wall will be equal to the sum of the momenta of the two. So no, that is not true, because although it's not really related to collisions, it would be the sum of the momenta of each block at t equals 0 would be equal to the sum of the momentum of the blocks at t equals delta t. So this says just block 1. And then lastly, if the collision between block 1 and the wall is not elastic and the two blocks have an inelastic collision, then the momentum of block 1 before it makes contact with the wall will be equal to the sum. So no, that's not true, because again, it's just mentioning block 1. So let's stick with A. Let's see if that's the right answer. And it is. There you go. Thank you.